Good afternoon, Meteorologist Tuttle here with you. It is about 1:15 here on Thursday afternoon. Been watching some storms developing up there in northern Oklahoma, and those have been pretty strong, producing some pockets of damaging wind and some large hail. And now there's going to be a couple of them that may have the threat of producing a tornado. So we're going to take a look at that activity up to the north. So thanks for watching and for joining me. Make sure you tell your friends and family about AT's weather so they can watch alternative source of weather information as we track these storms up here into northern and north central Oklahoma. So Oklahoma City Metro, quiet for now, but they may not be the case here as we head for the rest of the afternoon. So the Weather Service has been watching this storm up here around Kingfisher area, and it has just recently issued a tornado warning on it. This just came out a moment ago. So Weather Service continues for a tornado warning for northeastern Kingfisher County and central Oklahoma until 2 o'clock. There's a storm capable of producing a tornado. Again, not yet. Located 4 miles west of Dover, moving east at 30 miles per hour. Golf ball size hail associated with that. Dover right now is in the immediate path of this particular storm. And since it's a slow mover, doesn't have any other communities involved in that. And Dover roughly is looking at about 156. That's how slow moving this thing is. And they've had some times where they've looked a little bit better in the data than in other times as far as the rotation is concerned. It's been mostly kind of broad, weaker rotation, but in the last few radar scans, it's picked up a little bit better here on the back end of this in the RFD section. So what we're watching for is this little region right here to kind of tighten up. In other words, this is the green that comes toward the radar site. This is red that blows away, and you want those to get tighter and closer together. When that happens, you have yourself a tornado, as far as indication goes on radar. So we do have some storm chasers out. I've noticed, been watching the live feeds up there from the TV stations. But we're going to just track these storms as they develop, and I'll hang on as long as there is a threat for a tornado, and which may be the rest of the afternoon. We'll have to wait and see. But regardless, this is the big picture, which shows all the activity up here in northern and north central Oklahoma. There is some new development trying to get going out here to the west. Western Oklahoma, and then this little guy here southwest of El Reno. So I do expect some additional thunderstorms to try to get going in this area, and then they would be moving east across the rest of central Oklahoma. So right now they're kind of in the north central, but Oklahoma City will likely get into some of that thunderstorm activity here for the remainder of this afternoon, especially as this guy here starts to slowly intensify west of El Reno. So a pretty good echo associated with this developing in the radar data, but keep in mind, the hook echo does not guarantee a tornado. It just means that the storm is rotating, and you can see Dover lined up there about 128. That's the only storm right now that looks like it has a potential of producing a tornado. But we're going to watch that because others may change. For example, this guy up here around Enid, it does have some broad rotation with it. Let me switch over here. And then kind of northwest of Enid toward Carrier, so you likely see a lowering with that one. Same thing for Orlando and Mulhall. There's a little weak rotation right in this area here, but it's very weak and it's very broad, so it's not anything to get too concerned about. Right now, Dover, that storm there in Kingfisher County, is the only one that looks like it has potential to do that, which is good that there's not more than one right now. The forecast for this afternoon will call for these storms to continue to develop and move over the same areas here. It'll be a long day as far as storm development is concerned. They usually hold off until late afternoon. This time around, they're starting earlier because the forecast from the models that we've looked at the last couple of days had indicated little to no capping inversion in the atmosphere. In other words, nothing to prevent storms from developing. So all they need is a little push in the right direction, and they can get going. So this is that cluster up here in northwest Oklahoma City, around the town of Dover, and just west of there. Matter of fact, let me give you the actual roadways. This is County Road. Looks like 8220 comes right up along the river, the Seminole River. And then another county road, 2830. So that's where that location is of the circulation center. And if I look underneath the radar, we're looking at, of course, a bunch of farmland out here. I don't see any significant communities involved, which is good. But I do see a few farmhouses, which is non-good. So you guys in the farmhouses, hopefully you've got your weather apps, your NOAA weather radio, your TVs, all that kind of stuff going so that you know what's happening with the storms out there. All right, now that's a particular look at the Dover situation. Let me back this out a couple of frames. So this is the rotation signature on the radar. So what happens is you watch this, you need to watch it do a couple things. You need to watch it tighten up, and then you need to watch the colors change over from green to yellow to red to pink, which is right here on the scale on the left side of your picture. So when that happens, that's when you get the tornado indication that shows up with the radar signature. So we go through time here. You saw it briefly strengthen there for a minute, but then it kind of weakened again. So it's not overly impressive right now, but it is a weak circulation here in Kingfisher County, just south and west of Dover. All right, let's take a look here at a few things. So I'm going to bounce around to a lot of stuff because I need to see a lot of data, and we're going to never mind. Let's see. They did launch a sounding, and I did want to look at that. It's just not posted yet. Storm Prediction Center did highlight this region here for the mesoscale discussion. Thunderstorms are expected to develop across western through central Oklahoma for the afternoon and gradually spread east. Supercells with isolated large hail will be the initial main threat, but isolated damaging wind and a few tornadoes are also possible. The latest objective analysis of the atmosphere continues to show unstable conditions around 3,000 Cape across the region, supported by steep and mid-level RAPS rates above the rich low-level moisture with surface dew points in the low 70s. And we also have temperatures in the mid to upper 80s, so we're not hurting for instability for once for a particular storm. Latest trends show a few showers developing in the warm sector, blah, blah, blah. Some remnant capping may still exist, but it should gradually weaken as temperatures rise into the low 80s. RAP analysis, let's see, blah, blah, blah. Bulk shear, environment should support discrete supercells as the initial storm mode with large to very large hail likely, while low-level rotation are not particularly large with a 0 to 1 kilometer storm relative helicity between 100 and 150 meters squared per second squared. Isolated tornadoes cannot be ruled out given the degree of instability in a very moist boundary layer with relatively low LCLs. That's a mouthful, right? That's a lot of scientific stuff. So I just needed to read what they were thinking on this current event. Let's see. So now that I've got that out of the way, let's go back here to the radar again. So we're just now tuning in. We have one tornado warning in effect for this cluster of storms up here across the northern half of the state. It's the one down here in Kingfisher for the coming up on the town of Dover. There was weak circulation associated, embedded within that. And the radar continues to show it on the weaker side, so it's trying to get a little tighter in that region, but still a little broad. And then the one in Orlando, same kind of ideal. It's been kind of weak and broad. There's a rotating wall cloud associated with that, so that's been the case here for a while. These have all had kind of rotating wall clouds with them. But just because you have a rotating wall cloud does not mean you're going to get a tornado. All right, so let me see here. We've got the severe weather outlook here for the rest of today, painted in orange for the enhanced color. The tornado threat in green, which is low. It's not excessively high, but it's there. Severe timing, of course, is basically now across the north, and then we have a secondary wave, an evening wave over central and southern Oklahoma. Flash flooding is a potential. We talked about that in the forecast updates. And then for Friday, I mentioned southwest Oklahoma. The Weather Service hasn't drawn the map yet to include this area, but this could be a region for some storms that roll through in this area, mainly wind and hail, but something to keep an eye out for if the timing works out for Friday afternoon and evening. If it comes a little too early, then there won't be as much instability, but that will be where the next round of storms would be. Otherwise, the rest of the state looks pretty good for Friday. So that's some good stuff. All right, here's a look at the surface map, and I do show you the temperatures in the low 80s up here, getting into the mid 80s out here in western Oklahoma. Let's see, as far as any boundaries are concerned, we've got a little bit of an outflow boundary that's sagging something like this, which is what is firing off those storms out there currently. The tail end kind of washes out. But this is where the initial focal point is, and that's why we're seeing those storms rotate in this fashion. And remember, if they can kind of stay along a boundary, they can get a little extra vorticity ingested in them for tornado production. So boundaries are important to watch this time of the year. The actual cold front itself is out here in the panhandle, dragging southward. You see temperatures falling. They fall quickly into the low 70s back here. So that's where the front will help to trigger the secondary line as it pushes into northwestern Oklahoma later this afternoon and into the evening hours. Let's see, if you look at the overall picture again, let's see, a lot of south winds, temperatures in the 80s. Let's go with the satellite viewpoint. On the visible satellite view, we do have those storms that are bubbling up here on the viewpoint up here in northwest Oklahoma, and there's that one around El Reno that's getting going. And you can see a lot of Q, which is basically a lot of overall instability. This little batch of mid-level clouds right here indicates probably a jet streak of mid-level winds, which is what's going to help to keep firing off these storms once that pushes in. And the overall trend here for the winds, this is key element here, all kind of out of the southwest. So let me explain something why this is important. We're lucky they are in the configuration they're in now. If the winds were all like this today, you wouldn't be looking at an enhanced risk. You'd be looking at probably a high risk of tornadoes. Big difference in the vector of the surface winds. Now, with the movement of the storms, that will help offset some of those southwest surface winds to help produce a tornado. But for the most part, that's the saving grace for today, which if we take a look at the 88D, the next ride down at Norman, it does show kind of a southwest wind at pretty much all levels, including down at the surface. And for tornadoes, you really need to have these winds turn with height, not go all the same direction. So that's the weakness today, at least in the early part of the day. Now, forecasted soundings had shown that may change late afternoon and evening, but for the early part, this early stuff, it's going to be very hard to get a tornado within this type of an environment. It's not impossible, it's just very hard, which is, again, a great thing. So a lot of these storms are going to rotate, and you're going to have the weather guys jump up and down every 5 minutes, and whatever, it's fine. Point being is that we still may never get a tornado out of it, even though there is an official warning. And if it does happen, it may just end up being brief and small, because that's what the atmosphere is supporting right now. So that's fine, but things can change, and the boundary is the wild card. So even though the atmosphere itself may not be all that conducive, if you can get that little surface boundary, that kind of changes things and tips it back in the favor of a tornado. So overall, the environment isn't that supportive. But if you can get a surface boundary interaction, then that changes the game just a little bit. All right, so that's we have to watch these storms up here as they develop. So nothing changes on that one. Let's go to the Dover one. The algorithms that produce or predict tornadoes, by the way, they're saying the probability of a tornado is about 3%, but it's got a 91 and 95% probability of severe hail and damaging wind. So that's the big difference there. All right, so this Dover storm, it's not really doing much of anything. Yeah, it fell apart, the rotation center with it. So at one point it had a better, tighter couplet as far as the mesocyclone signature. So the Weather Service went ahead and issued a tornado warning for that, but as we've gone through time, it's weakened, and it's not as nearly much of a factor. All right, let me take a look at these up north. Probability of a tornado are all in the single digits. And I will give you a hint at this number. I've used this probability for a while to see how well it does at predicting tornadoes to develop. And this is research stuff that's been going on for about 2 years. It doesn't do all that well, but it does give you clues and hints. And it's usually more of a change in the number, ramping up, if you will. So, for example, in Kansas of the day, they had a tornado, I think it was about an EF2, EF1 strength that happened multiple times in multi-vortex, and it did some damage. This is in northwest Kansas. And the highest the algorithm went for probability of a tornado was 44%. Now, obviously there was a tornado, it should be 100%, right? So the algorithms aren't perfect. It's just some research stuff to kind of see, another input of data, let's just put it that way. All right, so make sure if you are watching this coverage to share. There should be a share button on Facebook immediately. And that way you can share this feed with others. And I'll be on as long as there's a threat for a tornado. And then I may sign off, then I may get back on here as time goes on throughout the day. Let's see. I have to read something here real quick. Talk amongst yourselves. Okay. All right. Text support email came in. Hey man, it never ends. When you're the lone man, you got to do it all. So I got to pause this coverage to answer a technical support email. So it's fine. But anyway, so if you haven't noticed, there is a tornado watch in effect. Let me go get that graphic up here. Let's see, it's going to be this one. So that's this box in yellow that covers Oklahoma right here. So it's all the way to the Kansas border. So this entire shading in yellow, which is 2/3 of the state, by the way, does include Oklahoma City, Norman, down south toward Paoli, Palos Valley, almost to Ada. But from there eastward through McAllister, Fort Smith, back up toward Miami, Nowata, and then back out here toward Woodward. So that's it. So that's the Tornado Watch box, and it goes for the rest of this afternoon. And those are issued from the Storm Prediction Center. Now, there are other storms to Missouri. These are severe thunderstorms. Therefore, they're under a pink colored shading, which is for a severe thunderstorm watch. So that's what they're having to deal with up there. And then a flash flood watch, and underneath all of this, just because of the heavy rain we're going to get and some flash flooding potential. All right, so I'm going to look at a few things here. So the Weather Service is going to allow the tornado warning to continue, but they noted what we talked about a moment ago, which was the RFD kind of dominated the storm. It lost its rotation. So even though it may not produce one in the near term, they didn't leave the warning going because that is where the rotation signature is. I do see on these live chases, I see some scud and some lowerings. They look scary, but in reality, they're just par for the course with severe thunderstorms when you do have a rotating updraft. All right, let me look at something else here. Just coming in. I'm going to go to, let's do this. Low level, 1 hour. So the strongest areas of rotation, believe it or not, there's pockets of it up here in Osage County that moved north to east from there through Bartlesville. So there was a stronger rotation in some of those storms. Rotation just means it's spinning in the mid-levels and down toward the surface, so you might get a wall cloud out of it, and maybe sometimes a funnel. There was no tornado warnings in effect during that. And then the secondary batch is in this new stuff that's developing out here in northwest Oklahoma. Let me update this, auto-update. So there you go, just updated the map there, so that will take into account the newest data. So a little spot up here and a little spot down here. So those are two storms. There's a little tiny spot up here. This is rotation tracks over the past hour. And like I said, a big cluster up here in northeast Oklahoma. So when you do get this, you do get a potential for some hail. Let's see, severe hail index. Let's see here. Max expected hail size. Definitely golf balls. And the swaths of hail over the last hour. So most of the swaths of hail have occurred in these thunderstorms here in north central Oklahoma, and then some of these up here across the northern part of the state. So those are hail swaths out there. All right, just taking a look at a lot of different maps because I like to get all kinds of data when I do these live storm coverages, so I make sure I have everything I need to give you all the information that you need. All right, let me jump through. Now, my friend Jeff, he was storm chasing earlier on that Mulhall storm. Let's see, about half an hour ago. He did not have the best service. That's an issue sometimes for storm chasers. You're in a great spot, but you can't get good cell phone service to get your video out. So that was his deal a moment ago. All right, let me see what else we got. Let's take a look at the latest on how storms should evolve for the rest of the afternoon. So this is a look at the latest HER model. So it captures what's happening currently. Okay, it's a little slow. It does try to bubble up more storms here in central Oklahoma through 3 o'clock. Those waves of storms move out across eastern and northeastern Oklahoma, so a busy afternoon for Tulsa. And then you see redevelopment back in the same areas as that front starts to move in to northwest Oklahoma. Here's 6 o'clock in the evening. You can see more storms developing along that front, which is moving through about like this. And so it'll trigger more additional storms. And these are all on an outflow boundary from the storms from earlier. So we've got two kind of boundaries kind of congealing to get some storms going. A lot of these have helicity tracks in them, indicating some hail with them and some mid-level rotation for sure, and probably a potential for a tornado. Those will kind of congeal in more of a squall line that moves into southeast Oklahoma as we head into 11 o'clock and midnight tonight. So by midnight, most of the storms are pretty much out of the state. If you're here in Oklahoma City, our biggest storm window for the second round is going to be roughly between 6 and 8 p.m. and 9 p.m. it starts to move south and out of the city. So that will be our main window here for some of those nastier storms later on. But we still could have these little bubblings of stuff that scroll through here between now through 3 o'clock. So kind of it's a two-part window. Let's see here. Let me look at, I want to see the change in the forecast sounding between the two events as far as what the models think. All right, so the models think same idea on the shear that we looked at currently, so they have a right idea. They still have amounts up to around 4 inches on the hail size, though, at most. And should a tornado form, they do like the idea of maybe an EF2 tornado, potential EF3. Again, this is nothing set in stone. This is just based on looking at analogs and some of the parameters. So if a storm were to develop, it would need that boundary really to kind of get to that level. Now let's go into but that includes you guys here from central, northern, northeastern Oklahoma. Anywhere we got those first storms out there currently. And then we're going to go into the 6 o'clock hour. Let's see how the storm mode has changed any. Winds are a little stronger. Otherwise, same look, southwest flow. Hail size is still up around 3/4. Tornado strength about the same. Potential EF2. Let's see here. As it goes to 7 o'clock, 8 o'clock, let me just get a look at what's happening down here. So this is a little different. This has a little bit of a better shear profile with it as far as the directional shear goes. So it still has potential for a tornado in that stuff that's here in the 8 o'clock hour in South Oklahoma City and moving through. Let me check here. The late evening, same kind of idea, but the winds are weaker. See, it's a trade-off. You get weaker wind speeds but better directional shear. In those particular cases, you're probably going to have maybe some QLCS type tornadoes along the leading edge rather than more supercellular. But regardless, that's just kind of how the mode looks to appear looking at the latest data here. Let's see a second here. All right, let me go into, let's see, that's the other model's not going to be in yet. Not quite. All right, so we'll just wait for the newer data to come in. So the main models that we use run 4 times a day, and then this little high resolution model runs every hour. Let me see what the tech model did this morning. It did fairly well on how things evolved today. And when we looked at that, the forecast last night, it kept most of the stuff across the northern third of the state, and it kept Oklahoma City dry until the main line came in the evening. Now the run this morning, let's see, how's it doing? So there's 1 o'clock, right? Well, that's what it thought was going to happen at 1 o'clock. So it's late to the party. It does have the idea, though, some bubbling some stuff up here in central and northern Oklahoma. And those got the little helicity tracks with it. Let's see, as we go through time, that first wave starts to move off to the east. That secondary wave never really gets going with the front, probably because it lingers this stuff too long and there's some substance on the back end. I don't like the looks of this one as far as things how they should progress and develop. But it is what it is. That's the data that's the model putting out. Doesn't always mean it's going to be right. Anyway, so I just wanted to look at that. Let's see, I think there might be a new... Ooh, good. This is in. Okay, so this is the forecast sounding from Norman to showcase the lack of a cap. In other words, we should have a nice little red line that goes something like this if you had a cap, but we don't. It goes right through here. So as a result, there is nothing to prevent storm initiation. All it needs is a little push. So we're in an uncapped environment. The lapse rates up here between 700 and 500 millibars through the growth layer of the hail zone. So the freezing level is about 13,000 feet. And in between this, the 7.5 degrees Celsius per kilometer growth rate indicates some really large hail. And that's why the discussion of large hail is on the table. At the current status of this environment, when you don't heat it up a few more degrees, it had hail size mostly under 2 inches, basically golf balls. But once we get a little more heating, that'll probably bump it up over 2 inches, which is what's currently happening. So every little degree matters when it comes to severe weather indices and the strength. All right. One thing I do like to look at on occasion is the environment that these storms are going into. In past historical references for climatology, all right, so all tornadoes, we have to see how many of these check marks we can make. So significant tornado parameter, we're on the low end, but we're in the box. Supercell composite, yep, we're in the box. Cape values, yeah, we're actually out of the box. We have a lot more instability. Effective shear, though, we're too low. We're on the outlier curve. Effective helicity, also outlier curve. But we have good low-level condensation levels. So we're missing a couple ingredients for all tornadoes. That's why I was telling you the atmosphere isn't exactly perfect or ideal. We're missing a couple of things, which is going to help to limit things. So that was all tornadoes. If we look at significant tornadoes, which means EF2 or higher, we're out of all of the qualifications except for the cloud level base. Other than that, we don't reach it to any of them. And then the Cape instability, but the rest of them are weak. If we go to discrete or cluster-like, we do get those a little bit better, but we're still kind of lacking on the shear. All right, and then the QLCS type tornadoes, again, we're lacking there too. So honestly, when we look at this is the Climo map here. In other words, all of these tracks here are tornado tracks, all in the database going way back. And comparing what we have out there now. So I like to use this too, just as another source of data. It just kind of reinforces what I told you earlier, is that we're just not quite 100% conducive for that. So let's go back here, take a look at the Dover storm. It's just a big multi-cell line echo cluster at this point, so it's lost whatever supercellular look to it had earlier on. The tornado warning course continues because they did not want to cancel it just in case, but it never really did much. And looking at the data, there's nothing there. So that's good. All right. Let's see here. The one around Stillwater, Orlando, it has really weakened as well. So not much going on there. And then in northern Oklahoma, just your garden variety thunderstorms, heavy stuff up there, a lot of lightning. Let's switch radar sources. Go to this guy. Let me see if I can get a better view of some of these storms. New little storm there east of Woodward in Woodward County. All right, I see some pockets of wind gusts up around 40 to 50. I don't see anything crazy. And the strongest storm is the only one going on is down there in Kingfisher County. And it doesn't look all that great. So the Weather Service is going to shift gears, and now they're going to focus on flash flood warnings for these storms. So about 2 inches has fallen in northwestern Kingfisher County. And looks like guidance is showing another 2 to 3 inch spreading southeast. So that's a lot of rain in a short period of time. Remember I showed you some of those models that were up around 4 or 5. I think there was one at 7 inches of rain, where they try to pinpoint where this type of a situation happens, very slow moving. Supercellular type storms, you do get some flooding associated with that. So that's what's happening out there currently in Kingfisher County. So guys, be careful for some flash flooding. Let's take a look and see what the rainfall totals look like. And we'll do two things here. Actually, yeah, let me do this. All right, so it's a little better. That way you can see it, the data. So if you back out the strip, right? So these are, remember how I told you last night it's called training, kind of go over the same area. So you have multiple storms over the same track. So in this particular case, the track is this right here. And then last night we had the long-lived storm complex that went like this before falling apart. and you got another one in Kansas. So on these long tracks, you get these heavy type storms, you can really dump a lot of rain. So last night, for example, was up around 2.5. There's almost 3 inches of rain in some of that area. And then the stuff here that came out of Watonga to Kingfisher, and Loyal and Hitchcock, again, there's 2.5 inches of rainfall. That's close to 3 in some areas. Looks like there's a spot just under 3. And that continued up through Marshall and Orlando. So you do have some flash flooding when that happens. So that is a look at the rainfall totals. All right, so we only have the 2 warnings here in central Oklahoma. There's a few guys up around Stillwater, and the one out here in Kingfisher. This was for severe thunderstorms, which is basically 1-inch size hail, and 60-mile-per-hour winds is the minimal criteria for that. Let's go take a look at the Piedmont area. That little baby storm there, northwest Oklahoma County. I'm going to switch over to another radar. So what I'm probably going to do is I've given you what the forecast is. I've given you all the indices of what's currently ongoing, which is why there's no widespread tornadoes at this time. What I'll probably end up doing is just taking a little break and then coming back once one of these storms actually starts to do something that gets us back into the tornado threat. So I'll be doing that more than likely. Here's a little cell in Piedmont. It's a heavy rainmaker on the north side of town. This is out northwest of Edmond. Speaking of Edmond, you do have a little shower that's popped up there. Looks like no lightning with any of this stuff yet, so it's just now kind of going. Matter of fact, I wonder if that's the remnants of what happened in El Reno earlier. Let me do this and do a little replay, because I think it was. Yeah, here's the guy that came in at El Reno. Oh, it fizzled. Here comes the next one coming in. That one, yeah, it fizzled and redeveloped once it got just a little bit north. So it is a potential. Well, that is strange. Never mind. So the atmosphere is uncapped from the sounding, so really this shouldn't have died. It should have kept going. So what that may mean is that the weakness in the cap isn't universal. In other words, there's still spots where the SIN values are still holding pretty strong and prevent some storms from getting rooted, which is what it looks like that happened. But then now that it's up in this area, just a difference of 20 miles, and all of a sudden it's into a more favorable region. So there might be where the cap is eroding overall, but there's still pockets where it's holding for the time being to suppress some of that activity. Otherwise, that thing should have went gangbusters if it was completely uncapped. That's the one thing I'd like to get as one day is a grid of the capping layer, the SIN values in real time. That'd be a game changer when it comes to severe storm development, forecasting, all that kind of stuff. That's huge, because right now all we have is just that one point, that one sounding in Norman to represent all of Oklahoma, and that's a silly way of doing things, but unfortunately it's the only way we can do it with the current climate of cost and resources. Let's see. But I do know there is a drone network out of OSU that was doing some low-level analysis for like some pseudo soundings. So that activity, that research is ongoing, and that will help as well for future events. Let's see. All right. So I think I'm going to be signing off here. There's a new mesoscale discussion. Let's go read that. I think I was going to do that earlier and I got sidetracked by a squirrel. So let's go back. Yeah. Okay, so this is the new discussion. For that, I'd read you the one that had come out a couple hours prior. Threat for large to very large hail, damaging wind. A couple tornadoes will remain highest across the northern third of Oklahoma the next couple of hours. Scatter storms continue to develop along the northern third of the state. Several supercells with large hail have already been observed. While low-level photographs are relatively small, effective bulk shear from 35 to 45 knots will continue to support organized storms, including supercells. Advanced radar indicates some storms are interacting with a southward moving outflow boundary. While this boundary is likely only partially modified at the present time, further modification could locally augment the tornado threat this afternoon. So that's that bound interaction I was telling you about that can flip the scales into more of a positive tornado environment versus what we currently have. So the tornado warning is going to expire for that storm up north of Oklahoma City. So if you haven't noticed, I call it like I see it. I tell you the way things are going to transpire, and I tell you what's going to happen, then it happens. In other words, I even tell you kind of what goes on behind the scenes for what the Weather Service thinks when they issue the warnings, and how they address the potentials out there. And I explain that to you because the deal is you never want to ignore a tornado warning, right? They're there for a reason. They don't always pan out, but they're there for a reason. That's because potential is there. That's not always a guaranteed. So when you watch me, for example, and I break it down, then you can say, okay, there's a warning out there, but there's not a tornado currently, and AT says there won't be. So I can breathe easy, but I still want to either be in my shelters or I want to be very close to taking shelter if it's coming your direction, right? So for example, let me give you an exact idea how you break this down. This, I took the radar off. Let me put the radar back on. Okay, so there's the radar, right? Now, if you notice, this red polygon is for the tornado warning. Now, that's a large area. Okay, that's a very large area. That's almost the whole county size of Kingfisher. So who takes cover in this polygon? Well, technically you should, right? But with modern day technology, and when you watch me, for example, when I can show you these things, we can narrow that down further. So if I take the radar back off, you'll see this little yellow line right here. See this little yellow line? So that's the actual track of the particular warning from the tornado. Now it will adjust and update with time as it maybe moves positions or changes depending on if it touches down or not. But in theory, it's this 2 mile plus or minus area of interest when it comes to a tornado warning versus that big old red polygon. So that's how you can get a tornado warning that say you live way up here and you're like, well, there's no tornado anywhere near me, and maybe the tornado is down here. So this additional information here helps you decide on what you need to do. So I'm able to show you that here when I do my live broadcast. All right, so that's a look at that. Storms are still kind of congealing into a line up here in northern Oklahoma. Let me switch sites up there. One last little look-see. Let's see if anything jumps out at me. No. A little bit of wind up here in Pond Creek. That's probably up around 55 miles per hour for those storms up there. A lot of lightning. This one up here that moved out of Piedmont to northwest Edmond, now heading up toward Guthrie, is getting a little stronger, but it's just actually I don't even see any lightning with it yet, but it's just a heavy rainmaker. All right, let me look at the bad wind profile from Norman one more time to see if it's changed any. And scale goes from left to right as far as updating the time, and it's over a 1 hour window. So in the 1 hour window, there really hasn't been any change in either speed or directional shear at the lowest 10,000 feet. Aloft, it's actually more of a southwest wind versus a west wind. It actually hurts tornado development just a little bit, but most of the action for tornadoes occur in the lowest 10,000 feet as far as shear is concerned. That's the bigger influence versus mid and upper levels. That was more conducive for healthy storm separation and supercell structure, that kind of deal. All right, let's go take a look at the Tulsa wind profile up there. Oh, did I hit the wrong one? No, I didn't. I got the right one. So we're going to take a look, see how the atmosphere looks in northeast Oklahoma. See if that's changed any. Ah, it's a good little shot. While I'm waiting on that, there's a shot from my roof cam, AT's weather cam, and you can see that little storm that we looked at north of Edmond, heading up toward Guthrie. So this is, let's see, the cloud base is in the center part of the shot. If I zoom in a little bit, you can see there's nothing underneath it. Like, for example, there's no wall cloud or anything, just a flat baseline. So nothing exciting about this little shower, but that's what it looks like. All right, so luckily, if, or unluckily, it's probably really unlucky, if I get a storm that moves too close here in the city, I'll have a good look at it, although I'm not sure I want to see what's coming my way. But anyway, so it's out there. All right, let me go to the Tulsa radar up here. Let's see, did we get, oh, wrong one. This is what I wanted. Let's do a little panel here. All right, bad wind profile. It's the same as Oklahoma City, really. All southwesterly, about 20 knots. The other thing is, really, for tornado genesis and structure, you really want these lower level winds up to around 3,000-4,000 feet to be greater than 15 or 20 knots. They're on the borderline. It's what is that? Is it a 15? Yeah, it's 15 knots here at 1,000 feet. Goes to 20 knots at 2 and 3, and then 25 and 30. So it's not exactly ideal. It's another weakness, and as to why we're not getting tornadoes out there at the moment. Now, all these conditions or indices are expected to change a little bit and become a little bit more conducive with time, depending on how things evolve with the current state of affairs, with the storms that are out there now, and then any outflow boundaries and interactions and all that. And we'll deal all with that as time comes. So for now, what I'm going to do is I'm going to sign off and I'm going to get something to eat. It is just about 2 o'clock, so we've been on here for about 45 minutes. We covered the one tornado warning that did not produce a tornado, and if another one does happen, I'll get back on for that. So when I do, make sure you tell your friends and family about AT's weather, so they can track along with you, and you can help them bring down their anxiety. Also, in case for whatever reason I can't get back on, and for example, I got up this morning, Cox Communications had internet outage. I'm like, you gotta be kidding me! Of all days, you're gonna do this to me today? You should have seen see this vein? You should have seen this thing explode. I was like, don't you do this to me. But they fixed it by, that's why I didn't do a lunchtime live today, because I was down internet-wise, so I just waited till I could do this. And so I was out of commission all morning anyways for data. And I have a backup for Verizon, but Verizon screwed me. They took away my cell phone tower antenna that services this entire sector of the city. And then in the notes, it basically they just told me, sorry, good luck. I'm like, okay. So I go to T-Mobile and say, okay, give me a plan. So now I got 2 plans. I got Verizon and T-Mobile, and I'm trying to see which one's going to work better. Because T-Mobile doesn't work that much better either at my house. Apparently I'm in a really bad spot, even though the tower is half a mile away and it's clear line of sight. So I don't know what's going on with the tower as to why they have it structured the way they do. So, but that was my backup for uploading to go live, because I need bandwidth, obviously. And what you guys don't realize, when you watch stuff, everything's downloaded, and everything's set for downloading. You know, movies and things. They don't really donate a lot of bandwidth for uploading content. So you wouldn't note that unless you were a content creator and you need to upload live videos and stuff a lot, like I do. And then that's when you realize, oh, 5G, huh? 4G, huh? I don't think so. So you're limited that way. So I've been pulling my hair out about 2 weeks trying to get that resolved. So we'll see what we can do. But needless to say, I'm back up and running. So as long as Cox stays up this afternoon, it should be good. But use my weather app, AT's Weather to Go. It'll track all these storms for you. It'll tell you when lightning's in the area, danger storm is approaching, twisting storm alert. You get one of those, you better pay attention. It'll have a BTI number from 1 to 10. If it's in the low end, You should be okay. Just kind of keep an eye on it. Maybe start thinking about what you're going to do, your game plan for shelter for a tornado. If it goes to 4, 5, and 6, you may want to think about, getting in your shelter. It's not going to hurt you. And then continuing from that point forward to monitor it, or at least get really close to doing that. If it's a 7, 8, 9, and 10, don't even question it. Just hit for the shelters, and then you can monitor after the fact. So that's kind of how you use that rating threshold. It's a probability scale. Think of it like a confidence factor of a tornado within that storm. And it's called AT's Weather to Go. It's free on Apple and Google Play. All right. One last little look here at some info. So Weather Service just mentioning how right now the wind feels pretty weak, but with some energy coming in from the Texas Panhandle. The satellite view we showed you earlier, that should help to increase the wind shear with time later this afternoon and then this evening. So we'll see if that helps to increase the tornado potential for later on today. But for right now, things are relatively quiet in that department. But this good old thunderstorms, you can get a little hail, a little wind out of a lot of these. All right, I will come back with you later on this afternoon. All right, be safe.